Hello, today we are looking at electron configurations for the elements of the fourth period. In this period, s electrons, p electrons are filled in and d electrons are added. So the first element in this period is potassium. Its ordinal number is 19. The electronic form, if we write it down in full, looks like this: 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. But we said in the last lesson that this kind of writing can be written in the short version. And up to 3p6 is the element argon, the noble gas. And then we have the entry 4s1. And then for the elements that follow, I'm going to write down with the short entry. I hope it will be clear that everything else is also the same as argon. The next element is calcium. Its ordinal number is 20, and its electronic form in short record will look like this: argon 4s2, but there can only be 2 s electrons. And after 4s, according to Alvao's principle, the next element, and this is the element scandium, its number is 21. And it starts to have a D sublevel filling in, but the third level, then it will have a configuration like argon 4s2 3d1. Next to scandium is titanium. Titan has a 22nd serial number. Its configuration will be like that of argon, and 4s2 3d2 are added. Then vanadium, which is located after titanium, is an element that accordingly will have 3d3 filled, but we will highlight, let's say, the chrome element. The fact is that this element, and its number is the 24th, has a special moment. It is called the failure of an electron. And it would seem its configuration would have to be after 4s2 3d4. That is, it would seem that this configuration should be like this, but in fact this does not happen, and the configuration is correct for him exactly like this: 4s1 3d 5. It's called this moment of electron failure. And such a failure of electrons has a number of elements that are in the periodic system, and such elements are not very many, but nevertheless they will have to remember 2 for the fourth period. That would be chromium and another element, that's the element copper. After chromium, the next one is manganese. Let's show you what his number will be. His number is 25. Its configuration will be like argon, then 4s2, 3ds, making 5. Then we'll skip ahead and get to the element copper. Copper is an element with the order number 29. Its configuration, it would seem, according to the alpha Bow principle, should be built like this: 4s2, 3d, 9. But it doesn't really happen that way. This form of recording is not correct, and in reality it turns out that such a feeling will be correct. Argon 4s is 1, but 3d is 10. Thus, in the fourth period, there are 2 such elements in which there is a failure of electrons. These are chromium and copper, and they fill in the beginning. It turns out S under the level and then D, but from S under the level, 1 electron moves to D under the level. This is due to various reasons, including, for example, for chromium, this allows it to have a larger number of unpaired electrons. And for copper, the reason for the failure of the electron is different. In this case, copper completes the third energy level to the end. There are 18 electrons then, and at the last level, there remains an s electron, which will be unpaired as if formally the filling should be D. but these two elements should definitely be well remembered. The next one after copper and zinc will be filled with 4s2 3d10. Let's see now how, for example, the element arsenic will be. Its order number is 33 argon. And it will have 4s2 at the outer level, 3d10. The d under level is completely filled, and then it will have 4p3. Then let's show for the element bromine. It has the ordinal number 35. Up to the 35th element, the p under level is filled, as is bromine itself also. That would be 4s2, 3d10, 4p5, and closes the fourth period with an element called krypton. It's number 36, and then it would have a configuration the same configuration as argon 4s2, 3d10, 4p6, and so the fourth period is complete. What I would like to draw attention to once again is that when we fill in electronic configurations for elements, we adhere to a number of rules. The rules for filling energy levels under the Albau principle level. Here we repeated this using the example of potassium. Then you need to remember that the electrons are filled in a certain order, that there are 3d ahead. It would seem that 3d is the third level, but it is filled only after 4s. And this is explained precisely by the Albau principle, but in fact this is due to quantum numbers, with a more complex distribution of electrons in watts. Then the levels and sublevels are filled in a certain way. At the beginning there are 4s, then d is filled under the level, and then p. But you also need to remember that there are a number of elements that have their own characteristics, in this case chromium and copper, which have a special effect of electron failure. What you need to pay attention to when you are asked about these elements, this fact should not be forgotten, because this is a feature of these elements, and in the next lesson we will find out for which other elements of the periodic table this special effect is observed. And we have shown you how the fourth period is filled to the end, which levels and sublevels are filled for these chemical elements. Thus, the fourth period consists of S elements, P elements, and D elements, because the electronic configuration of these atoms is filled in this way. Goodbye.